Hi there. In this video, we'll look at a second example that reviews how to factor trinomials. Once again, factoring a trinomial is simply a matter of using the distributive property in reverse. And so we're engaging this rectangle diagram sort of in the opposite way from the way you would if you were multiplying binomials. Here we're presented with the area of the components of the diagram. We have 3x squared. We have between the two blue areas a grand total of -5 groups of x, and the lower right corner consists of -2. And if we start thinking about ways that we could write the length and width of these components, what comes to mind immediately for 3x squared is 3x times x. And what comes to mind for -2 is two choices, 1 times -2 or 2 times -1. In fact, I can think of four choices, perhaps 2 times a -1 or 1 times -2. So let's just try those choices and see where this leads. If I make this choice, 1 and -2, I get this diagram. And if I multiply the lengths times the widths, I get 1 times 3x and -2 times x. And together, when I combine these, I'm getting 3x minus 2x, that's 1x. That doesn't correspond to the problem, so my initial choice was not correct. So let me just clear that out of the way. We tried it and it didn't work. Let's try it the other way and see if this is correct this time. So again, we have 3x squareds. We'd like to get -5x between the two of these, and we get -2 over here. With that, we can again start writing down the dimensions just as we did before, and hopefully this time we'll have it correct. 2 times 3x would give 6x, and -1 times x would give -x. But together these make 5x. I really wanted -5x, so I feel like I'm close, but a sign shift should tighten this up. So rather than +2 and -1, let's try -2 and +1. So I'll shift these accordingly, and hopefully this will work. -2, +1. 1 times x gives x. -2 times 3x gives -6x. And now I think we are in great shape, because when you combine -6x with x, you do indeed get -5x. And so here we have a representation of the four components. And if we analyze the length and the width of the figure, we can produce the factorization of the polynomial. As always, if we were to multiply the two binomials, we'd go from C to B to A. When factoring, we're just doing those steps in reverse. Hope that helps. Thanks for watching.